Good morning, kids. Today's class, we are going to discuss about the projectile motion for complementary angles. We'll start with first this particular topic. So I'm going to choose now here. I'll choose two particles. There's a particle 1 and particle 2. Particle 1 I'll project. It will move in a red color path. This I shown. And it will have a range r. Then what is the angle of projection of the particle 1? Let it be 90 minus theta. Then the angle of projection of particle 2, let it be theta. This theta, 90 minus theta, they'll become complementary angles. The particle 2, now the particle 2 will move in this particular parabolic path. Both will move in parabolic path. So we are going to compare the overall, what about the range, time of flight, and what about the height ascended for the complementary angles. So first I'll start with the H1. Time of flight will calculate. T1 equal to 2u sine theta 1 by j. How theta 1 and theta 2 are related? First, we should have the basic equation. I think theta 1, if theta 1 is equal to theta, what about theta 2? Theta 2 will be 90 minus theta. We'll have this one. So this will be 2u sine theta by j. What about the time of flight? 2u sine theta 2 by g. This should be equal to 2u sine of 90 minus theta by g. Sine of 90 minus theta will be, so sine of 90 minus theta will be cos theta. So the time of flight of this will be 2u cos theta by. They'll have different time. They'll have different time. We'll compare the maximum height ascended. H1 equal to u square sine square theta 1 by 2g, which is u square sine square theta by 2g. H2 equal to u square sine square theta 2 by 2g, which is u square sine square 90 minus theta by 2g, which is equal to again cos square theta by 2g. So what do we expect now? Time of flight, they'll be different. We'll go for range. Range equal to u, both are projected the same speed. Look at this one. Both are projected same speed. So therefore now this will be u1 cos theta 1 into t, which is u cos theta t1 will be 2u sine theta by g. What about the range due to the second projectile cos theta to theta 2? So this will be u cos of 90 minus theta. This will be 2u cos theta by g. This will be u sine theta 2u cos theta by g. Finally, we'll end up with, so therefore what we can compare, R1 equal to R2. What about the time of flight? T1 not equal to T2. What about the H1? H1 not equal to H2. I think that's what I'm indicating in the diagram. Check it. In the diagram, we have things very clearly here. What about this range? This side? H2 and H1, they are different. Ranges are equal. But what about time taken? The time taken of this and this will be different. These things is what we are concluding. So for complementary angles, what is the basic condition? The range will be equal. The range will be equal. And what about the height and time of flight? They will be different. Okay, we'll have one example itself. No? Here I brought it. So we have the clearly you can see this particular thing for 15 degrees. The range for you can see the range for 15 degrees will be equal to that of 75 degrees. And similarly, the range for 30 degrees will become equal to that of 60 degrees because these angles are complementary angles. The range will be equal. And for which way and for what it will be maximum range? The maximum range will be, we will calculate here. R equal to u square sine 2 theta by g. For theta 45 degrees, so 2 into 45 will be sine 90 degree. Therefore, the maximum range will be u square by g. So, what is the maximum range? U square by g. What about these ranges? They will be different. And the maximum range will be for 45 degrees. Okay, I think almost all things with example I'm giving, you need not to bother much anything. So these are basic idea. The time of flights will be different. Then T15 degrees will be less than T75. Time of flight has to be different. Let me write like this. Then definitely H75 degree maximum height ascended when it is projected with an angle 75 degree here. Definitely that maximum height ascended will be more. Similarly, we'll go for T time of flight for 60 degree will be greater than that of 30 degrees. Then maximum height ascended for 60 degree will be greater than that of 30 degree. I think these things I am showing it here. You can check it here. I'll show for H75 and this will be you have comparison here only you can compare things like this. There's a one for complementary angles, the range will be same and the time of flight and the maximum height will be different here. There's one basic idea. Okay, we'll go for the next topic. The same projectile motion. Next one more we have that. So again, once again, this person will kick the ball and it will impart a velocity u, and because of the weight and the velocity, it will move in a parabolic path. When it is moving in parabolic path, this ball, at one instant you can see it is at same height, no? At two different instants of time. Means at t equals 0, I'll kick the ball. Let's have this weight mg. It'll be easy for you. At two different instants of time, the projectile will be at same height. Let me choose this one. You can see this one. It will be at same height at t equals 0. At time t1, here it will have velocity and it will have the same speed here. It will not. Velocity will be different, but the speed has to be same. And let's go for other things. Here, u cos theta, u sin theta, Vx, u cos theta, Vx, this will be Vy, u cos theta, u sin theta. At time t equal to t1, it will be here. At time t equal to t2, it will be here. So we are projecting from the ground at point 2. It is a ground. Then let me call this as A, this particular point as B. You can see colors. Okay, fine. So what is T1? T1 is the time taken to move from O to A. What is T2? T2 is the time taken to move from O to B. And let it be C. And time of flight is what? TOC, this is equal to time of flight. Time taken to move from O to A will call T1. Time taken to move from O to B will call T2. Time taken to move from O to C is what? The time of flight. Let's see how all these three are related. So we are trying to get a relationship. So let this projectile be at an instant. We'll write equation for H. Here gravity, G is acting. We'll write all the possible equations. H is equal to u sin theta t minus gt square by 2. Now you have to ask question. Sir, why this H positive? Because you are measuring displacement in the direction of initial velocity. That's why H is positive. And you are measuring this G opposite to initial velocity because G is downward. So therefore this negative sign. Rest all, I think when you are applying equations of motion, the sign for displacement and acceleration depends upon the initial velocity. We are discussing motion of the body, equations of motion along y-axis here. Then there's a quadratic equation, we'll solve this. This will be gt square by 2 minus u sin theta t plus h equal to 0. Quadratic equation, t equal to u sin theta plus or minus u sin theta whole square minus 4 minus 4 AC. 4 A is G by 2 and this is H by 2A. 2 into G by 2. This will end up with u sin theta plus or minus 2GH whole divided by G, or this will break up into two parts. The first one is T1 u sin theta G minus and what about the other one? The other one is u sin theta by G plus u square sin square theta minus 2GH whole divided by 2. There are two times are there. We'll add up these two times. So means what is happening? The projectile will be at same height at two different instants of time. Right? And what are those times we are having? This one. We'll add up these two. What do we get? T1 plus T2. T1 plus T2 means I should add up these two. Let me use. I'll substitute the value. Then this T1 plus T2 will be 2u sine theta by g, which is nothing but equal to time of flight. Oh, we are having very beautiful equation here. So what is the conclusion? Time taken to move from O to A plus O to B is equal to time taken to move from O to C. Or if you break up further, TOA must be equal to TBC. It has to be. In a projectile, this is what happens. Means what time it will take to move from O to A, it will take same time to move from B to C. And what is the time interval between from as it moves from A to B means? So we can calculate that TAB also. So how to calculate TAB? TOB minus TOA. This will be directly equal to u square sine square theta minus 2gh I'm writing it. What is TAB? Time taken move from here to there between the same height. This will be useful. So somewhere in our formulas, this is going to help us a lot. The reason for that, T2 minus T1. So this quantity will get added up to this. These two will cancel out when you add up T1 plus T2. So like this, all when the projectile will be at same height twice, it will be at same height at two different instants of time. And what are those instants of time that we are calculated here? And some of those instants of time should be equal to time of flight. So what is the basic conceptual question? How do they ask you? The projectile will be at, let it get safe. The projectile will be at same height at two different instants of time, and the sum of those heights and the sum of those times must be equal to total time of flight. I think there's one statement we have conceptual. We should the projectile will be the same height at two different instants of time. This sum of this time is equal to time of flight of projectile. And you have this statement of for this statement, the above thing is what explanation. Without the all this mathematics, no, we can't justify this statement. In physics, there's nothing called like a conceptual question. Everything again is numerical only. Even if you see any one statement, so what you have to do, like you have to work out a numerical. You have to show that how that particular statement is justified with some examples. We have to show it. We can't just read this statement. Okay, sir, this statement. Okay, fine, sir, we will remember. No, This everything is background needed, all this. Okay, kids. Now we'll take the next concept. Next topic will go. Okay, we'll continue with the same idea. So I'll project the ball with a speed. It will move in a parabolic path. Twice it will be at same height. At what are the instants of time at t equal to t1 and t2? The projectile will be at same height. Then what about these positions at t1, t2? The ball will have horizontal distance c, and from the point of projection at distance b, and this will be the range. Let's see that how this a, b, and r are related. We'll try to bring this equation. Now, if this is a, so what is this distance will be? R minus a. If this is b, this has to be r minus b. And we know the time taken to move from O to A is equal to B to C. And the horizontal, good morning kids. We had the problem, so it was we have completed. So at t equals 0, this ball will be kicked by the footballer. So there's a ball. Because of the velocity imparted and the weight, it will move in a parabolic path. Okay, fine. This one. Then it will strike the ground at point C. Everything is a ground. Then look at this one. At two different instants of time, it will be at same height. At two different instants of time, the projectile, it will be at same height. Everything is a ground. Everything is a ground. Fine. At two different instants of time, it will be at same height. Then what about this? This distance given by A, this distance let it be B. And the time taken to move from O to A is T1. Time taken to move from O to B is let it be T2. And we know from TOA should be equal to TBC. These things also we know it. And this distances, if this is A, because this will be the range. Fine. If this is A, then this should be equal to R minus A. If this is B, this should be R minus B. Let's write some possible equations. We'll see what conditions will come in this one. So already we know what are the, from the previous discussion, we brought expression for T1 and T2. Let's compare that A and B. That's all I'm only interested. So here, from here, what we can write? R minus A plus A plus B, A plus I'm trying to relate A, B, and R, how they are related. For that, we know one thing, TOA is equal to TBC. And what will be the horizontal component of velocity should remain constant. Vertical component will be changing. Let's define. So what is the distance A we can write? Distance A should be equal to U cos theta into T1, or time taken to move from O to A, which is U cos theta into T1. Then similarly, the distance R minus B, U cos theta into TBC. TBC is equal to TOA, which is equal to T1. So this will be A From these two equations, what we can write? A equal to R minus B, or R equal to A plus B. What mean to select it? Sum of this distance plus this distance should be equal to the total range. Are you getting no? So I'm giving an information like this: the sum of this distance, this one, this distance, and this distance, that should be equal to total range. That's what I derived an equation for this. Sir. So these are all. Then what are other equations we have? The time again, time taken to move from O to A plus O to B equal to time of flight. This already we derived it. That is already we derived it. The previous topic we have derived it here. So in projectile motion, all these conditions are very, very important, which you should remember. Can we calculate the time interval between them? The time interval, this one. Yes, we can calculate this. And we can calculate this distance also. What is this distance? B minus A. Can we calculate this distance will be B minus A. So what is B minus A? B minus A should be equal to U cos theta into TOB minus TOE. Distance between 2 points, horizontal distance between 2 points where projectile will be at same height. We can calculate this also. So all these are some information which we should know. So we'll take the next one. If a okay, kids, these are the some topics are there. So coming class, we'll discuss few more conditions for the projectile motion. Okay, thank you all of you.